Okay, here we go. First, the whole unit is about electrons. First, though, we have to talk a little bit about ions. Does anybody know what an ion is?
A charged particle.
Charged particle. So a charged atom or group of atoms. For our purposes, that definition fits. Okay. There are two types of ions. A cation and an anion. Make the door, please. A cation has what kind of charge? Positive. So does it gain or lose electrons?
Gains.
Loses. So an anion is negatively charged. So therefore it gains electrons. Thank you, sir. All right. The easiest way to remember which one's which is that cation has a T. The T looks like a plus sign, so it's positive. Does that help anybody? Or not? Okay. Any questions about either one of those? Okay. I'll let you get a chance to cover that down real quick. All right. Then we're going to talk about the electron configuration. Can I erase this?
Not yet. I mean, yeah, I guess it doesn't matter. I know it.
Okay. You were given all the answers, so. All right, there's some concepts we need to know first before we get into the actual configurations. First one is called energy level. It's also called principal quantum number. It's basically how much energy an electron has. Know that this E like this means energy and this one means electron, right?
Wait, what?
The big E is energy, little e is electron.
Okay.
Make that a little more clear. Not quite. You're being recorded. All right. Next is sublevel. It's also orbital shape. It's the shape of the area where the electron exists. And those are denoted by the letters S, P, D, or F. That's their names, so to speak. Does anybody know what a hierarchy is?
Something higher up above it.
Well, you have something that's in levels. Right? Okay. So that's not wrong. Okay, so energy level is the top. Okay, it's the broadest category. Then you have sublevels. Then you have the next thing, it's called an orbital. Okay, an orbital is an area in which an electron exists, and there's a maximum of 2 electrons per orbital. So it goes energy level, sublevel, then orbital.
It's pretty dope.
So think of this as city, neighborhood, then your house.
2 people max.
Then it goes to state. Actually counts.
Well, then your atom actually will be your state,
States in your house.
or the whole electron cloud. Okay, the orbitals, like we said, have shapes, or sublevels. They're S, P, D, and F. Okay? These are the sublevels. Okay, so S orbitals, or S sublevels, can only have 1 orbital. Therefore, they only have 2 electrons. These can have 3 and 6. These have 5 and 10. Fs have 7 and 14. This is probably the most important chart in the whole unit,
So right.
for sure. Okay. And just remember, you can always remember that since each orbital can hold 2 electrons, these just double. So if you want to remember one color on that, it should be gold. Can I erase this side?
Possibly.
Yes.
Okay, there are some rules for doing electron configurations. There's 3 main rules. Okay, first one is called the off-ball principle. And what that says is that you fill the energy levels starting with the lowest energy level. Off ball. Next is Hund's rule.
Okay.
Okay, each orbital within a sublevel must have 1 electron in it before you can add a second. Imagine that an electron, or excuse me, a sublevel is a school bus. Okay? In each orbital are a seat on a school bus. Each student is an electron. On a bus, everybody wants a seat to themselves, right? Okay, so they fill up, everybody gets a seat by themselves, and when we get so many kids on there, you start having to double up, right? But usually all the seats are full first, correct? Somebody get that, please. So same thing happens with electrons. You put 1 in each orbital first, then you go back and put the second one in. So you can kind of think this is the bus rule. Xander, please.
Just like a sloth when you get
Actually, it might hurt you.
There's no bite to it.
She will hurt you. Don't you?
No, I think that's considered assault.
In fact,
It's not a soul.
Salt and pepper.
And then-
what? Alright. The next rule. The next rule is called the Pauli exclusion principle. Pauli. Alright. What it says is in each orbital, the electrons must have opposite spins. One must spin one way, the other one the other way. Okay? What?
It's spelled principle wrong.
Principle?
Oh, I wrote it like that so it could stand.
Principle.
Principle.
It's a principle.
My brain overrides my hand.
So it's kind of like the left spinning Beyblade and right spinning Beyblade slamming into each other.
Yeah, basically.
Totally. Alright. Questions? Alright, you gonna erase this up?
No.
Sorry.
Two.
Oh, yeah. Alright. Okay, we're gonna do 3 different types of electron configurations. The first type that we're gonna do today, and part of tomorrow, is called the box configuration.
Box of D. I spelled box with a D.
The box with a D.
Yeah, I put a D.
The dots configuration.
Oh my gosh, I did that too.
It's a disease.
Okay, so let's take oxygen for example. How many electrons does oxygen have? Normally.
8.
If it's neutral.
8.
8 is correct. So 8 electrons. So we have to write this configuration for 8 electrons. Let me pull up the electron configuration chart that you'll have to use. I'm gonna make copies of this. It's not today.
Sweet. Sweet.
Orient.
Are those your debate dates? We held debates overnight.
No more. No, we usually have one of those if you're trying to. Okay, while we're waiting for that to warm up, you can kind of see it. 1s is the first level. 1 is the energy level. The number 1 is the energy level, and s is your sublevel. Okay. How many orbitals can we have in the s sublevel on that chart? 2 electrons, but only 1 orbital.
Yeah.
So you draw 1 box.
Box 010.
And Kaylee just told us we could have 2 electrons in there. So you write an arrow up and an arrow down representing the opposite spins of the electrons.
Dope.
Okay? So now I have 2 electrons. According to our chart, after I go 1s, where do I go? What's next? 2s. I'm gonna turn that light off so I can see this a little bit better.
Whoa, they were colored?
Yeah,
Didn't even see it.
I know. So I'll turn the light off. 2s. So it's still an S, so still 1 box, 2 electrons, up, down. So I have a total of 4 now.
Yes.
Okay? What's next?
3S.
3S.
No.
4.
2p.
2B.
Because look, I go in here, then here,
B.
and back.
Oh.
Okay, twist.
Oh.
Okay.
So 2 boxes.
No.
Tupac.
P's have how many orbitals? How many orbitals do P's have? Let's give it to you in that chart.
3.
3.
3.
So 3 boxes.
Ooh.
Goodness.
Gracious.
Alright, I need 4 more electrons, don't I?
Yes.
So I have 1, 2, 3, 4,
One
5,
of those trick questions.
6, 7, 8.
Whoa.
See, our bus seat rule came into effect here, didn't it?
Possible.
I put 1 in each one. I came back and put the second one.
Which one has the ball?
You.
Now I have 8 electrons. And I'm done.
Should Zach.
Kaylee, you're confused.
Zach's right to me.
Okay.
Wow.
It is 3S.
That's pretty cool.
After 2P, yes, it would be 3. But no, we're done though, because we have 8 electrons.
Oh. Wow.
I'm sad.
Yeah, we're done.
See, that's all we needed. 1, 2, 3, 4, 5, 6, 7, 8. Alright, let's do another one.
We don't have enough time.
Alright, homework then.
Homework.
Homework.
You
Do
what?
box configuration for aluminum.
Okay.
Alright? That's your homework. Get started on
Look that
that.
up.
400. Know what? How many electrons?
Wait.
It has 13.
What are we supposed to?
Wait, what are we supposed to figure out?